Recently we had an issue with a B&M 250 power charger. Driving along, it stripped the input shaft at the coupler. This is a coupler that bolts onto the front of one of the gears inside the case. If you can see in there, the spline is stripped out of it. You can see the shaft here where it's stripped off. If you look inside the coupler, you can see that there's not full tooth contact in there. You can see at the end there where it's stripped off. It's only about 3/5 of the way in there, so we only got about 3/5 worth of spline engagement. It seems to be pretty common on B&M blowers that they don't have full spline engagement. Actually makes a rattling sound. This blower actually did have that rattling sound. And mostly you think it's the gears, but it's not. It's actually this spline that's stripping away in there. This thing was making more noise than it normally did before it stripped out. When it did strip out, it sounded like a really wild gear drive. So we're going to get a new coupler, and we made up this spacer, Swiss cheesed it for lightness because this thing's going to be spinning at about 9,000 RPMs. Made this spacer to bolt onto the sandwich actually between the new coupler and the drive gear, and that will extend the drive coupler out to give us better spline engagement. We're going to try and get a new shaft if that's possible, but at this point it seems to be a little bit difficult to get one. But with better spline engagement on a new coupler, that's going to really help out. We'll actually have, even with this old shaft, we're going to have more spline engagement than we did before. So it seems. Yeah. So when we get that new coupler, we're going to take a look at that and make some measurements. Today we're going to be addressing a problem that we've been having with this B&M 250 power charger. This is the nose of the blower right here, and the bearing sits in here. It's a single roll ball bearing, and it's only 15 millimeters wide, and that seems to be a bit of a problem because on the front here where the drive is, where the drive pulley mounts, we extended it about, I believe, 3/8 of an inch to create clearance for the accessory drives in the front, and that makes the problem even worse. So what we're going to do is we're going to get a double row angular contact bearing and put it in here. In order to do that, we're going to have to cut this whole lip off, and this is the back, in the back of the bearing, where the bearing sits up against there. I don't know if you can see it here very good, but basically this lip here is what the bearing sits on, in the back. So basically we're going to have to cut that whole thing off when we bore this bearing bore deeper. So what we did was, behind here we cleaned it all up and we made this. Okay, we had an interruption there. Anyway, so here we go. We machined out the back of this a bit, get it all cleaned up, because we're going to cut the bearing stop off to accommodate a longer bearing. Longer bearing is going to be about 7 millimeters longer. So we're going to have to cut this whole back piece out. And we made this new one. This new piece is going to go in here. And we're going to screw it in there with these 6 millimeter screws. We cut the heads down a bit to reduce the diameter to get it closer to the walls here, because when we bore this out, it's going to be pretty close, and we didn't want the bore to be too close to the threads of these screws. So these are 6 millimeter screws we're going to use. We'll mount this guy in permanently. Put an extra lip in here to try to retain more oil for the bearing. So basically right here is going to be just a bit more of a lip to try and hold a little bit more oil in here. And we'll see if that works. This is actually an extremely poor design. If you look at the 671 blowers, they come with double row bearings. If you look at this blower, it comes with a single row bearing. It's actually relying on the rotor bearing to support the back of the shaft through the coupler, and that's a pretty bad idea. It creates a lot of noise. So you hear a lot of weird noise in there. And the drive pulley hangs out the front of this quite a bit. It's a 2-inch drive pulley, so it's going to be hanging out of here at least, off of this thing, at least 2 inches, plus the spacer, at least 2.5 inches. If you look at the 671s, the drive pulleys actually go over the nose, creating much less pressure on the bearing. And the 671 type bearings are double row bearings in here. So it's a much more sturdy setup. Seems to be a setup that's not engineered nearly as strong as the 671 type blowers. So we're going to get all that mounted up in here and machined out. I do not have the bearing yet, so I will not machine this yet. I need to get exact measurements on the bearing to get the proper machining spec. And we hope that works out. Okay. Here's the new bearing we got. This is the old bearing. The new bearing is about 50% wider than the old bearing. Quite a bit of a difference. It is double row And we're going to bore the nose of that blower out and hope this bearing fits in there correctly. This is what happens to the shaft when you have poor spline engagement. It just ate the end of that shaft off. We're also going to cut this back here. I took a practice cut on it already. So we're going to have to cut this back to about here to accommodate the new bearing. We put a new coupler on it. The new coupler is quite long. The new coupler comes about to here, maybe to about here, with the extra spacer we put on it. This end part is just toast. Apparently these shafts are made out of unobtainium because you cannot obtain them. What we may do is to get a marine blower drive shaft and modify that to fit this application. That's going to be a crapshoot because it seems like getting information on any of this stuff is also in the unobtainium realm. Here's our drive pulley, driven pulley. Originally these had only 4 bolts, but we decided to upgrade to 8 bolts for strength and aesthetic purposes. That worked out pretty good. We also had to put a spacer on this also. This bolts to the pulley here. It goes on this way. We made this adapter to space it out for V-built drive clearances on the front of the engine. So that's about 3/8 of an inch there that we came out. So that does not help our situation any. Hopefully this new bearing will solve most of our problems. And hopefully we can get a new marine style input shaft and modify that for this application. We're not going to bore you with the boring machining details of this. We're just going to try and make it happen. Off now. Okay, so here's our finished project. That's the 8-bolt conversion for the drive. Oops. Not much to see here. This is what it looks like from the back. As we mentioned earlier, we machined out the whole bearing stop, and this is the new bearing stop we made and bolted that in place. We skipped all the boring machining part. You want to watch machine shop stuff, look for Tubal Cain. Tubal Cain has good machining videos. This is not about machining, it's about B&M 250 blower. There's a slight amount of play here that I don't like. Kind of hard to see it, but let's see if we can. Very difficult to see it there. But it is there, even with the double roll bearing. It has that. Well, we're gonna put it in and see what it does. Okay, here's the next phase in our seemingly never-ending situation with this B&M 250 power charger. I was unable to get the input shaft, so what I did was take a gamble and bought this Marine B&M 250 blower input shaft kit. Comes with a new coupler that we've already machined down to get full spline engagement. Now we're going to have to machine this area down to fit this bearing. This is the Marine blower bearing, and it's about 1 inch. This street 250 blower bearing is about, oh, I'm not really sure. I believe it's 25 millimeters. But we're going to have to machine this down to 25 millimeters. It's quite a bit bigger than that now, because this is like a 1 inch shaft here, and this is going to be machined smaller than that. Kind of an ugliness over here, but not a big deal. That's all going to be machined off. Cut the shaft down. Going to be quite a bit of machining on this. We're not going to bore you with any of that. We're just going to get to it. And this should get full spline engagement. We'll put that double row bearing on here, and we'll see how that works. Okay, so this is it. Finally got everything back together. Not a whole lot to see here. Only thing you might really notice is that there's a spacer in here. Other than that, it looks like it should. That Marine blower shaft did work out. We got it all machined down, and that fit in there real nice. Got a really good spline contact now. We got a full spline in there. It runs much smoother, sounds a lot cleaner, belt tracks better. So basically, if you have a street B&M 250 power charger and the input spline is no good, you can get the Marine shaft, get the Marine shaft kit, and you can get that shaft machined down to fit in here. If you choose to go with the bigger bearing, you can also get that done, and works out pretty good on this one. Got a few 100 miles on it now, and all seems good. Hopefully it all works out good.